Alright guys, so we go to the question 5. So the question 5 say, which of the following statements is or are true? A, y equal to x squared minus 1. This says define one-to-one function. Define one-to-one function is x, and the second one x squared plus. So the first question is quadratic, right? The second one is a cycle. So x squared plus y squared equal to 4. Define one-to-one function in x. Means when it cuts at x in the vertical test. In the vertical test, that's what they say. Define one-to-one function in x. Okay, for B, x squared plus y squared equal to 4. Defining one-to-one function x. When the meaning x means when you draw the vertical line, because vertical line cutting at x in x. Okay, see y equal to 9 over x, which is hyperbola. Define one-to-one function in x. Okay, so let's go guys, right, without wasting time. So let's search for the first one and see if it's true. So the first one, that's quadratic right there. So we're gonna say let's take equation, let's take quadratic, but of course you know it's function, but let's just do it. So for A solution, so our equation given equal to y equal to x squared minus 1. Okay, so this is quadratic, so we can get x-intercept, y-intercept, etc, etc. Okay, so for x-intercept, y equal to 0. So for x-intercept, y equal to 0. And then we can get x-intercept. So we're gonna have to look for x-intercept. Means what that means when you have a parabola, this is quadratic, right? Because that's quadratic. So if you don't understand quadratic, please let me know. I can make out another topic about quadratic. So I don't want to go deep down quadratic and start to explain to people how to solve quadratic. So now when x-intercept y equal to 0, so this gonna be 0 here equal to 3x squared minus 1. And this one can go over, so 1 equal to 3x squared, and then over 3 over 3. So this and this cancel, shows me, so x squared equal to 1 over 3, or you could have say, I can flip it, x squared equal to 1 over 3, and then square root, and then square root throughout. So x, this and this cancel, x equal to plus or minus 1 over square root of x. So these are x-intercept. You know what I'm saying? These are x-intercepts. And this one I could simplify further. If I want, I could say this, let me say plus or minus, and then I might rationalize the denominator. So to rationalize the denominator, because most of the time it's not good when you have a root at the denominator. So you multiply by the same thing up and down. So we multiply by square root of 3. Up and down mean the denominator. You rationalize the denominator. If anything you don't understand, please let me know. I can make a video explaining in detail how to rationalize the denominator. But for right now, I want to solve this paper, this sum student the same to me. So now we say we have a plus or minus, remember? So now if this plus is minus, so it's okay. So you have a plus or minus, and then 1 times square root of 3, and then square root of 3 times square root of 3 equal to 3. Whenever you have the same thing in root, let's say Mtwana Bano Academy times square root of Mtwana Bano Academy, this equal to Mtwana Bano Academy. You know what I'm saying? Because you can put them in a single root equal to Mtwana Bano Academy. How did you get this? You know how you get this? But it's not part of the, I don't want to go deep in other stuff which has nothing to do with it. Because I could put in a single root, m times m is m square, and then this and this can cancel equal to m. That's how you get. So that's what square root of 3 times square root of 3 equal to 3. So now these are x-intercept. So meaning we have a 2x-intercept. When y equal to 0, when y equal to 0, so when y equal to 0, we got the first x, which is square root of 3 over 3 negative, and another one when y equal to 0, we got a positive one, because plus or minus square root of 3 over 3 and 0. 3 over 3, if we can see it by that square root of 3 over 3. 0. So now what we're going to do, we got x-intercept. For y-intercept, when y-intercept x equal to 0, meaning when y-intercept, this x is going to be equal to 0. So 0 times 3 equal to 3. So now it's okay. I can just do this little space here. So I'm saying, so now for y-intercept, when y-intercept, x equals to 0. So what happened? I'm going to put it in this equation. What is intercept? Intercept, these are points where intercept, these are coordinates where the graph cut at. X-intercept means the graph cut at x. and y-intercept means the graph cuts at y. So when y-intercept always x equal to 0. So we're going to say, okay, so x equals to 0. So y-intercept y equal to x equal to 3 times 0. 3 times 0 square minus 1. And the y-intercept equal to negative 1. So it's 0 and negative 1. So we have all the coordinate of x-intercept and y-intercept. So we can draw a graph. Say, okay, so let's go. So we can draw a graph. Man, I think I can take out a paper here quick. So what I'm saying. Okay, so let's draw a graph. So graph is gonna be, it's quadratic, of course. Okay, so y-intercept, I think you got it here. Excuse me quick. Y-intercept equal to negative 1. But there was no need for me to do all this process, but you know, I just do it because, you know, some of the people sometimes they don't understand how to concept. So now we go, okay, so y-intercept equal to negative 1. Or you can see, oh, this is y-intercept. The last one, when x equals 0, this is y-intercept. So Cartesian plane, that's my Cartesian plane here. Y-intercept equal to negative 1. And x-intercept square root over 3 over 3. So positive and negative. So when this y-intercept, when x is 0, y equal to negative 1. And x-intercept, negative square root over 3 over 3. So this negative square root over 3 over 3. And positive square root of 3 over 3. So this is hyperbola, remember, guys. So it means, of course, this graph is going to come in concave or upward. That's a rough graph. But at the end of the day, if it's parabola, because just by looking, you can say this first graph here is quadratic. And if it's quadratic, it must be function. You know why? Because let's draw the vertical test now. Let's draw a vertical test. So vertical test. Okay, draw vertical test. So what do we see? We see the vertical test, the vertical line cut once at every point. So this is a function. Yes, it is function. Yes, it is function. It is function. I mean, this function given, it is function. I mean, the expression given is function. It is function. Why? Because when you draw vertical line, the vertical line cut once at each point of the graph, like how we see. So yes, it is a function because the vertical line cut once at each point of a graph, or of a graph given, or the graph we have drawn. Now we go for the b. So we want to see b if it's a function. So b is a cycle. Just like explain the previous equation, b the cycle. So let's go for v. So b, look, man. So this is a Cartesian plane, y, and this is x. If you remember from the, I think the first question, if I'm not mistaken, I explained about the cycle. So now, given cycle is x, the one that gives us x squared plus y squared equal to 4. So I'm going to write in the standard equation of a cycle. How the standard equation of a cycle? The standard equation of a cycle, let me use another pen. Let me use another color. Okay, you know, we got to put rainbow, man. Okay, so now we're going to say standard equation of a cycle is x minus h, or in the letter, x minus h plus y minus another letter. But most of the time they put h and k or a and b. So let's use h and k because the previous question used a and b. So I'm going to say y minus k square equal to r square. So let's try to compare with a given a cycle. So now this is going to be x. Since we don't have a h here, so we're going to say 0 square, because x minus 0 is x squared, the same thing, so it didn't make any change. And this is y minus k, means k is going to be a 0 square equal to r square. What is r square? Means it's 4, but a 4 is going to be like 2 square, which is 4. It didn't make any changes. So now what is our center? H equal to 0. We say whenever this sign are the same, you just say h equal to whatever number is there. So h equal to 0, and this sign are the same too. So you're going to say also k equal to 0. But if the sign of difference here, you're going to say k, if let's say this is positive and this is negative, say k equal to, you change the sign. And then what is our other? Radius equal to 2. So for that case, let's draw this cycle. So this cycle, this center of a cycle is hk, which equal to center 0, 0. So this is center, and a radius equal to 2 means 2 units from the center. Everywhere. You know what I'm saying? This is a radius 2 units, means 2 units from the center, 2 units, 1, 2, 1, 2, everywhere, because radius is the same, have the same length from the center to every point of a circumference of a cycle. So this is a cycle, but there was no need for me to draw all the cycle just by looking and know that's a cycle, but I did it just to remind you guys. You see what I'm saying? So now what we're going to do, we're going to draw the vertical lines. Let's draw a vertical line now to test if it's a function. Oh my goodness, not function, because vertical line cut more than once. Once. The vertical line cut more than once for every point. So like if you draw a vertical line, you cut more than once. So if that's the case, then it's not function. Cut more than one, then it's not function. You see what I'm saying? Okay. So the second one is now it's not function, so false. Second one is false. Okay, so now we go for the last one. So the last one is hyperbola. The last one is hyperbola. Excuse me. So let's say hyperbola, the last one. So the last one they say y equal to 9 over x. So hyperbola, I can draw for you the nature of hyperbola. Do you know what I'm saying? I don't have to go, like I said, you don't have to, but a final exam, they're gonna give you question. Remember, this is a multiple choice, but they're gonna give something that you have to work it out. So y equal to 9 over x. This is hyperbola. So what we're gonna do, I'll do straight away hyperbola. And if you have a problem with hyperbola, please leave a comment. Say, hey, I don't understand how the hyperbola works. Could you please make a video? I'm definitely gonna make a video. Please don't afraid of me. Leave a comment. Don't forget to subscribe. The more you subscribe, the more video I make. So you just tell me, man, I don't understand how the hyperbola works, and I'm definitely gonna make a video. So now let's go. Let's draw hyperbola. So they give us our hyperbola given is 9 over x. So they give us here. Let me use the rainbow pen. I don't want to use the same pen all the time. So okay, so given y equal to 9 over x. So how do you know hyperbola? Hyperbola always the general function general standard equation of hyperbola always say let's say f of x equal to k over the function denominator. It always has x. You know what I'm saying? Denominator has an x. For example, say x minus p plus q, something like this. This is hyperbola. So how do you know? For example, somebody gives g of x equal to negative 3 over x minus 5 plus 8. This is hyperbola. You know what I'm saying? Because the denominator has an x, on top here must be number, and this must be number. This is hyperbola. So if you look careful, this question here given, but you don't have to do all this bunch of problems, but I want to explain to you how it works just in case you forgot. So say we have a y, for this case 9 over x. So since there's nothing, you can say x minus 0, just to put in that same standard form. A standard form of hyperbola. So since there's nothing here, we're gonna say what? 0. So what are these? Those are asymptotes. What are asymptotes? Asymptotes are like fire. Man, what you mean about fire? It means it's not gonna be touched. It never be touched, man. You know, asymptote means a line which will never be touched. So now we're gonna say, okay, so let's represent, first of all, represent the asymptote. This is horizontal asymptote here. So now if we draw our graph, excuse me, let me just draw a graph quick. So before you do anything, you draw your asymptote. So what is the asymptote for this case? Let's use the other pen. The asymptote, the horizontal asymptote is 0. So horizontal asymptote you represent by dash dash. Horizontal asymptote is 0. So for this case, for example, this question, horizontal asymptote could be 8. It means it was gonna go at a dot dash line. And vertical asymptote always take this denominator. So this is a horizontal asymptote. And for vertical asymptote, always take denominator. So denominator of x equal to 0. That's how we get vertical asymptote. So for this case, we're going to say x minus 0 equal to 0. So 0 go over, so x equal to 0. So even vertical asymptote, our vertical asymptote equal to 0. So now we're going to draw vertical dash equal to 0. So like I say, these asymptote will never be touched. Do you understand what I'm saying? Okay, so we come in there. Let me show you, for example, this one, excuse me. So that when you go through your stuff also, you're not going to have it difficult. So we're going to say, okay, what is the horizontal asymptote for this case? The horizontal asymptote could be 8. So horizontal for that question, I mean, this example here has nothing to do with the question, but just to, you know how we do. So horizontal asymptote for that case, for that question right there, we say horizontal. This is not part of the question, like I say, but I just want you to understand how the things works. Let's go. So horizontal asymptote for that case is this one here. This is a horizontal asymptote. Horizontal asymptote y equal to 8. You see what I'm saying? Or sometimes they represent by q. So q equal to 8. Now we go for vertical asymptote. For vertical asymptote, take denominator of x equal to 0. So you could have say x minus 5 equal to 0, and then x equal to 5. So I could have drawn this also in a Cartesian plane. Man, how would you represent that one? It's easy. So we was going to say, okay. So now let's use that pen quick. Man, my pen just falling. My apology. Let me just pick it up. So now we go, okay, what is a vertical asymptote? Oh, horizontal asymptote. Horizontal asymptote equal to 8. So I was going to put in 8 here. So I'll say 80. And let's say this is my horizontal asymptote. And my vertical asymptote, x equal to 5. So positive 5 here. So I'll say vertical line dash. So these lines, they never be touched. Do you understand what I'm saying? And when you draw hyperbola always, you always first quadrant and third quadrant, but your axes are your asymptote. Meaning, how do you know? If this number here, excuse me, if this number here is positive, you see this number is positive, if it's positive, then your graph is just going to lie on a, let me use that a pen, your graph is going to lie on a first quadrant and third quadrant of asymptotes. If it's positive, if this number here, I'll say it again, if it's positive, or I can say if it's greater than 0, if this number, so just by looking at that number there, you could know where your graph lies on the first quadrant and third quadrant. You know what I'm saying? But if it's negative, and then your graph was going to lie on a third quadrant and fourth quadrant, no, second and fourth, first and third, if your letter here, if this one here, I'll say if it's greater than 0. But if this k means like here, you see it's greater than 0, so that's why it lies on first and third quadrant of your asymptote, first and third of your asymptote, not of your xy plane. But if this k is less than 0, if this k is less than 0, they say, okay, so it's less than 0. Then in reverse, it was in vice versa, it was going to lie on a third and fourth quadrant of asymptote. But now we're not dealing with the hyperbola, so let's go straight to the question. So for that case, for this case here given, we have our asymptote. We say our horizontal asymptote, we go 0 because we say 0, and we take denominator equal to 0, and then we get x equal to 0. So horizontal asymptote equal to 0 means horizontally 0. You know what I'm saying? And vertical asymptote, we say also, we take denominator of x equal to 0, so x equal to 0. So it's a vertical equal to 0. So these gonna be our asymptotes. It's like a fire. They never be touched. So for that case now, excuse me, so now we're gonna have to substitute. So where the graph is gonna lie, just by looking and know where my graph is gonna lie. Which number I'm gonna look? I'm gonna look, what's my question again? This is my question here. See, this is my question right here. Excuse me. So I go say, okay, this plus 0, that's a horizontal asymptote. There's nothing here, I'll say minus 0, because just like I say x minus p. You know what I'm saying? This is vertical asymptote. So now, since this number is positive, then I know of course it's going to lie on the first quadrant and third quadrant of asymptotes, not xy plane of asymptote. So now let's draw vertical line test now to know whether this function is not function. So let's draw vertical line test now. Okay, let's go. Once at every point, it cut once. So vertical line test has shown or proved, has shown that it cut vertical line test has shown that it cuts once at each point of a graph. I hope everybody understand, man. You know, sometimes I like to write like a doctor. It's for a graph. Don't worry about it, if a graph. Don't worry, just ignore that one. I'm just saying. I'm saying. So that's how you do, man. So draw a vertical line test. After draw a graph, say, oh yeah, it's a function. So this also is a function. So for that case, A and C must be of answer. Question 5, A and C. Man, most of the question A and C, man. Okay, so question 5, it could be A and C. Question 5. Okay, so option 3. Question 5, option 3. Question 5 is option 3. Let's see in the question. Question 5, man. Let's see again. Excuse me. Question 5. No, man. What are you doing? Option 3, man. Question 5, option 3. Question 5, option 3. Only C. But I think we got a face on also as a function, man. What about A? Oh, no. Come on, man. I apologize, man. Let's go back a little bit, man. Okay, so I have to correct this one. I didn't read my question careful. Yes, A and C the both function, but according to the question there, let's read the question careful, man. You gotta read the question careful. So I want to tell you, see, even me and made mistake here, man. The A one it is function, but they ask about one-to-one function. See, one-to-one function. It's not one-to-one function. The first one, because look, this is a first one, right? It is function, we agree, but let's draw horizontal line, because to test for one-to-one function, we have to draw, after we have confirmed the function, yes, it is, by drawing vertical line. Now we're going to have to draw horizontal line. Oh, so it cut more than one. So if you cut more than one, means it is function, but it is not one-to-one function. So this is false. It is function, but not one-to-one. So it's false. Because according to the question, they say is one-to-one function. It's not one-to-one function. The second one is not even function, so it cannot qualify to be one-to-one function or many-to-many function, etc., etc. But when you come to the third one, which is hyperbola, yes, it is function. Look. Now let's test for one-to-one function. How we test one-to-one function? We draw horizontal line. So now we go. So it is function. So we can test one-to-one function. Let's go now. Ooh. Let's use our pen, man. Let's use our pen, baby. Ooh. Oh, yes. Even horizontal line cut what? Once at every point. See? Once. If you draw, it's going to cut once. Look here. This is our graph, and this is our graph. Look. So we have tested function because it cut once at every point. Now let's test if it's one-to-one function. So see, it cut only once at every point. Once at every point. See, so this is one-to-one function. So only C. Question 5 is only C. Question 5 only C. So we go to question 6, right?